Hi, thanks for joining me. Before I get stuck into today's video, I've got a couple of announcements. Firstly, my computer has been fixed. For the last week or so, it just hasn't been working. So I haven't been able to edit videos. I've just been uploading from my phone. Couldn't have thumbnails or anything interesting like that. And also had to film all in one take, which is why the quality of the videos might have been a bit less than what you're used to. But I'm back to normal, so hopefully I can edit this video, add an intro and stuff, and all will be kind of back to normal. Okay, and a second thing, I've also made an Instagram account. It's at jpimaths. There might be a thing on screen or in the description or something like that. Go check it out. Go give it a follow. I don't really know what I'm going to upload on there. Maybe some like teasers for my videos and just some other random content as well. But go give it a follow if you're interested. Okay. Anyway, let's get into today's video. We're going to be doing something that's it looks similar to Pythagoras' theorem. We want to find all natural numbers a, b, and c, so all positive integers a, b, and c, such that a factorial plus b factorial equals c factorial. Okay, so obviously Pythagoras' theorem says, we have integers a, b, and c, such that a squared plus b squared equals c squared, but we're just essentially replacing the squareds with factorials, so it's a different problem. Okay, so if you want to solve this problem and not this problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so the first thing I notice about the equation is that there's symmetry in a and b. I can swap the roles of a and b, and that's not going to change the equation, because obviously putting the b factorial here and the a factorial there, it's not going to change any of the solutions. So I can assume, without loss of generality, that a is less than or equal to b, and then any solutions I get at the end, provided a and b are distinct, I can just swap the roles of a and b to get another solution. Okay, so without loss of generality, we have that a is less than or equal to b. And another thing to point out is that the factorial of any positive integer is certainly going to be a positive integer. So that tells me that a factorial is going to be at least 1. Okay, so that tells me that c factorial is at least b factorial plus 1. But in particular, c factorial is strictly greater than b factorial. So that tells me that c is strictly greater than b. So that tells me that c is at least b plus 1. Okay, so c is at least b plus 1. Okay, awesome. So now what we want to do is just divide this guy by a factorial. So we get on the left hand side 1 plus b factorial over a factorial, and that equals c factorial over a factorial. Now, one thing I want to point out is that if we have b large enough, then we're going to get some sort of contradiction. Okay, and let me just prove that. So if b is at least a plus 2, then let's look at the left hand side. What's b factorial over a factorial? Okay, well, b factorial over a factorial is going to be b times b minus 1 times dot 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 all the way up to a plus 1. And then what we're left with is a factorial, but then because we're dividing by a factorial, that will cancel. So this guy is just this thing here. But we're assuming that b is at least a plus 2. And this guy here is just the product of consecutive integers from a plus 1 all the way up to b. But this guy here will certainly include an a plus 1 and an a plus 2, because b is at least a plus 2. And at least one of a plus 1 or a plus 2, one of those numbers there is going to be even. So this is certainly going to have an even number in its product. So of course the product is going to be even. So b factorial over a factorial is even. Okay, so that means that we've got an even number here, plus 1. So that of course gives us odd. So on the left hand side we've got odd. But on the right hand side, c factorial over a factorial. Well, remember c is at least b plus 1, but in particular it's at least b, so c is at least a plus 2. So we can apply the exact same argument that we just did here and show that c factorial over a factorial is even. And of course we can't have an odd number simultaneously being an even number, so we have a contradiction. So b can't be at least a plus 2, so we've just narrowed b down to 2 values because we already know that b is at least a. So this implies that b equals a or b equals a plus 1. Okay, so we just narrowed down b to 2 values once we know what a is. Let me clean this up, let me wipe the whiteboard and bring this to the top of the whiteboard, and we'll continue. Okay, so we've narrowed it down to 2 cases, case 1 and case 2. Case 1 where b equals a, and case 2 where b equals a plus 1. Let's look at case 1 first. So we're going to assume that b equals a, and just plug it back into this equation here. So this is case 1. Well, just plugging in b equals a, we're going to get a factorial over a factorial, which is just 1. So on the left hand side we've got 2 equals c factorial over a factorial. Okay, and now what we're going to do is just look at this right hand side, c factorial over a factorial. So if c is at least a plus 2, well then what do we get on the right hand side? Well, this guy here is greater than or equal to a plus 2 factorial over a factorial, and this is just a plus 2, a plus 1, like so. Okay, but a we know is a positive integer, so this thing here is going to be at least 1 plus 2, so this thing here is going to be greater than or equal to 3, and this thing here is going to be greater than or equal to 2, so multiplying them together, we get that 2 is greater than or equal to 6. And of course, that's nonsense, that's nonsense, that doesn't make any sense. So that tells us that c can't be at least a plus 2. So that tells us that c must be a plus 1, because c obviously can't equal a because of this guy here. We have that c is at least b plus 1, so of course it's going to be at least a. Sorry, strictly greater than a. Okay, so we have then that c must be a plus 1, so we just got to check that that gives us a solution. So we have that c equals a plus 1. Just putting it back into this equation here, we're going to get c factorial over a factorial, which is just a plus 1 factorial over a factorial. But this thing here is just a plus 1. So we get that 2 equals a plus 1, and then obviously that gives us then that a equals 1. And remember, this is case 1, so when b equals a, so that then we have that b equals 1 as well. And c equals a plus 1, so c equals 2. Okay, so we generate one valid solution to this initial problem, namely 1, 1, 2. So a, b, c equals 1, 1, 2. And now remember, we said at the end, once we get all our solutions, we can swap the roles of a and b, but obviously because they're both 1, that's not going to generate a new solution. Okay, so that's case 1 done when b equals a. Let me clean the whiteboard and we'll move on to case 2. Okay, so we've just shown that there's one solution to this problem, 1, 1, 2. Let's see if we can find any more by looking at case 2 when b equals a plus 1. And again, we're just going to shove that back into this equation here. So we have 1 plus b factorial over a factorial, which is a plus 1 factorial over a factorial, which is just a plus 1. That guy there equals c factorial over a factorial. So on the left hand side, we've just got a plus 2. And then this guy here equals c factorial over a factorial. Now again, we're going to use an argument that if c is bigger than or equal to a plus 2, well, what do we get here? This guy here is going to be greater than or equal to a plus 2 factorial over a factorial, like so. And then just expanding the top, we get that this guy here is just a plus 2 times a plus 1. But of course, a is a strictly positive integer, so this thing here is at least 2. So this right hand side here is going to be at least, strictly greater than a plus 2. Because this thing here, a plus 1, is going to be at least 2. So we get that a plus 2 is strictly greater than a plus 2, which is nonsense, which doesn't make any sense. So we can't have c being at least a plus 2. So then we, I guess we're kind of done, because then that means that c must be less than or equal to a plus 1. But if we go back up here, we have to have that c is at least b plus 1. But remember, b in this case is just a plus 1. So this is just a plus 2. So we have to have c being both at least a plus 2, but also less than or equal to a plus 1, and that's impossible. So case 2 leads to no solutions. So our only solution came from case 1, and that was a solution 1, 1, 2. So there's only one solution to this modified Pi-thagoras Theorem, a factorial plus b factorial equals c factorial. I hope you have enjoyed this problem. It's a nice little fun one. Use some cool number theory techniques where you just sort of compare oddness and evenness and see if some variable's large enough, you're going to lead to some sort of contradiction. So you only really need to look at some small cases. Yeah, I hope you have enjoyed this video. Thanks for watching. I'll catch you in the next one. Have a great day.